Get ready for some hot stuff. Really? What would happen if the temperature reached 255 nonillion degrees? Well, that's a big number, huh? From ice ages to major earthquakes, doesn't it sometimes seem like our planet can handle just about anything? But what about extremely high temperatures? What if the temperature rose to 255 nonillion degrees Fahrenheit? What would happen to us and our beautiful Mother Earth? Can you say crispy critters? Well, here are all the answers you need to know. But before we bring the heat, don't forget to click that subscribe button before it melts and turn on post notifications. That way, you won't miss a thing. So, 255 nonillion degrees Fahrenheit, huh? Now, is that even real? By the way, in case you're wondering how to write that, 1 nonillion would be a 1 with 30 zeros after it. So 255 nonillion would be, yep, hotter than that. Now, if we're talking about the United States, the highest temperature ever recorded there was 135 degrees Fahrenheit in Death Valley. But the highest surface temperature ever measured anywhere on our planet was found inside a rock. It was a toasty 160 degrees Fahrenheit. And if we go explore the hottest planet in our solar system, we won't be heading for Mercury, the closest planet to our Sun. Nope, it's Venus, with an average surface temperature of 864 degrees Fahrenheit. As for the hottest hottie of our solar system, that of course would be our Sun, which burns at a temperature of 9,932 degrees Fahrenheit. Whew, I'm sautéing just thinking about it. Scientists have always been interested in experimenting with temperature levels. In 2012, physicists at CERN's Large Hadron Collider in Geneva, Switzerland, made it into the Guinness World Records, achieving the highest man-made temperature ever. They smashed together lead ions at 99% of the speed of light and created a quark-gluon plasma. No, this isn't something from the Ghostbusters movies. It's a state of matter that's believed to have filled the universe right after the Big Bang. As a result of this man-made collision, the temperature rose to 9.9 trillion degrees Fahrenheit, which is 250,000 times hotter than the center of the Sun. And whoever said science isn't fascinating? Well, as for 255 nonillion degrees Fahrenheit, also known as Planck temperature, it's the hottest temperature that could ever be possible in the whole universe according to the standard model of particle physics. For this temperature to actually come into existence, our universe has to reach thermal equilibrium. This is when two objects in thermal contact do not affect each other's temperature. Whoa, slow down. How about a simple example? Well, when you put a gallon of milk on your kitchen counter, these two objects are in thermal contact. They're touching basically. And after some time, their temperatures become the same. That's thermal equilibrium for you. So, in a nutshell, for this to happen on Earth, all the objects on our planet have to reach a temperature of 255 nonillion degrees Fahrenheit. Okay, let's imagine that it somehow comes to be on Earth. What would happen next? Well, scientists aren't completely sure, but hey, they'd be toast anyways. So would the rest of us. Actually, researchers do have some ideas. While there's still no exact scientific theory for how matter might behave at such a high energy level, they do know that going beyond the Planck temperature could be enough to turn the thing you're heating up, in our scenario, poor Mother Earth, into a black hole. But this black hole would have mass energy in the form of radiant energy, not matter. It wouldn't be physical. So, this black hole could dissipate and radiate away instantly, destroy the Earth, or do something pretty much beyond our imagination. As for our fate, well, that's pretty clear. We'd all go poof. Now, according to scientists, the closest we ever came to this unbelievable temperature is, unsurprisingly, just after the Big Bang. In the earliest moments of our universe, space-time was expanding so fast that particles couldn't interact with each other, which means that there was no heat exchange and therefore no temperature. But that lasted for just a teeny-tiny itsy-bitsy fraction of a second. But as space-time began to vibrate, the temperature rose dramatically. And that's the Big Bang for you in less than 60 words. Hey, we're just covering the basics here. So, moving on. Thankfully, our cozy little third rock from the Sun is nowhere near this terrifying high temperature. Whew. But we definitely do have some unbelievably hot spots that deserve a shout-out. For example, in 1922, in the small town of Al-Azizia, Libya, the world experienced the hottest air temperature ever, 136 degrees Fahrenheit. Yup, it beats the Death Valley record by 1 degree. Yet the World Meteorological Organization still gave it to the US since the usual record keeper in Al-Azizia wasn't there that day, and the reading was taken by an unexperienced observer. Yet, this is just child's play for the Lut Desert in Iran. Measurements from a NASA satellite taken between 2003 and 2010 testified that the land temperature in this place can reach a scorching 158 degrees Fahrenheit. Setting the bar a bit lower, there's also the town of Dalol, Ethiopia, which has the world's highest average temperature for an inhabited place, calculated at 94 degrees Fahrenheit. Heh, and you thought summer in your town was unbearable. Alright, we've talked about the hottest of the hot, but what about the coldest temperature possible? It's aptly called absolute zero, or minus 460 degrees Fahrenheit. It's at this point that atoms move as slow as they possibly can, bringing the temperature of an object down to the lowest it can possibly be. But unlike the Planck temperature, absolute zero is literally impossible to reach, and that's because it takes more and more work to remove heat from gas the colder you get. In short, you'd need an infinite amount of work to reach absolute zero. Still, scientists are just as hard at work experimenting with super cold temperatures as they are with the really hot ones. Just like the hottest temperature ever created in a lab, so was the lowest temperature. It was in 2003 when scientists at MIT announced that they'd chilled a cloud of sodium atoms to an astonishing 0.45 nanokelvin. Wow! Just so you know, that's like a hair above absolute zero, which is 0 Kelvin in the world of physics. Yet the record is still held by scientists at the Helsinki University of Technology, where they reached an even more dramatic temperature of 0.1 nanokelvin in a piece of rhodium metal back in 1999. And so they partied like it was, well, you know. Our solar system has also some cold characters floating about. There's a sort of rivalry going on between the furthest two planets from our Sun. The eighth planet, Neptune, does have a lower average temperature, at minus 350 degrees Fahrenheit, than the seventh planet does from the Sun, Uranus, with an average of a mere minus 325. But the chilliest planet award still goes to Uranus, where the coldest temperature ever recorded on a planet was measured, a very icy minus 371. Now you'd think Neptune would reach lower temperatures more often since it's further from the Sun, but that's not the case. Scientists aren't sure why Uranus is the coldest planet, but one of the most popular opinions is that it could be due to the structural components of Uranus itself and their effect on how the planet retains solar heat. Another popular theory is that Uranus's unique orbit is to blame. Plus, it's got a tilt like no other planet. This tilt makes Uranus spill loads of heat out into space, dropping the temperature to record lows. But let's go back to our beloved Earth, shall we? Naturally, the award for the coldest recorded air temperature on the planet goes to the Russian research station Vostok in Antarctica, with a result of minus 192 degrees Fahrenheit. And that's not the only record for Russia. In 1933, the Republic of Yakutia, which was part of the USSR at that time, experienced the coldest air temperature ever recorded in the Northern Hemisphere, a mind-numbing minus 88 degrees Fahrenheit. Well, I certainly won't be packing my bags and moving there anytime soon. The lowest temperature ever recorded in the US was minus 80 degrees Fahrenheit in Alaska. That's nothing compared to Vostok's minus 192, but don't forget it's still colder than the surface temperature on Mars, which, by the way, is minus 67 degrees Fahrenheit. Denali, the highest peak in North America that also happens to be located in Alaska, is considered the coldest mountain on Earth, with the coldest recorded temperature of -99 degrees. The list of other cold places on Earth continues with the Eureka Research Base on Canada's far northern Ellesmere Island. It's one of the coldest inhabited places, with an average yearly air temperature of around -4 degrees and dropping to -40 degrees in winter. That's chilly. And there you have it. From the scorching hot to the freezing cold, our planet is truly fascinating, don't you think? It is a pretty durable place, but that doesn't mean we shouldn't take care of our dear Mother Earth. I mean, she's done so much for us. Don't you think it's time we return the favor? So, do you have any other what-if questions about our world? Tell us in the comments below, and perhaps we'll make a video on it. Don't forget to give us a like and hit that subscribe button to stay on the bright side of life.